The marginal cost function is just the derivative of the cost function. So here's our cost function to find MC of x, their notation for the marginal cost function. You just need to take a derivative with respect to x. So the derivative of a constant is 0. The derivative of 65x is just 65. That's it. That's the marginal cost function. The revenue and the marginal revenue. So let's see, they have the price, demand, and cost functions. Okay, so this is the price of the product, wherein X is the number of cordless drills that they sell. So the revenue is how much money they're bringing in. They're selling an X amount, some unknown amount of cordless drills, and we're going to multiply that by the price, right? Because if you sold 100 items and they were $15 each, then your revenue would be 100 times 15, right? In that analogy, X is like the 100, and then this is like the 15. This is the price, because they tell us the price is 143 minus 0.03x. That's the revenue. And then marginal revenue, just like marginal cost, you just take a derivative. So we could distribute that x to make taking the derivative a little bit easier. This is 143x minus 0.03x squared. And then when you take a derivative, you get over here it's 143 minus 0.06x. Then part C asks for us to plug in 1,200 into the derivative of the revenue, which is what we have up here. That's just different notation for the same thing. Okay, so plug 1,200 into our marginal revenue. I'm not sure why they would use two different pieces of notation. Maybe there's a business reason why. I don't think so, but 143 minus that's 72, so I got 71 when I plugged in 1,200 in here. And then at a production level of 1,200 cordless drills, the revenue is, this is probably a drop down that says increasing. That's the one you'd want to choose because the derivative is positive. That means the revenue is going up. Okay, and then find R prime of 4,100. So this just means plug 4,100 into your derivative of the revenue up here again. So same equation, 4,100. Then we got 143 minus 246. That's negative 103. That's negative, so the revenue is decreasing is what we'd want to select there. A decreasing, a negative value for your derivative means something's decreasing at that point. So when they sell 71 cordless drills, they probably should try to produce more because revenue is going up as they produce more drills. When they sold 4,100 drills, revenue was going down, so they might want to back off and cut their inventory a bit. Okay, find profit. Profit is just revenue subtracted by expenses, so this is our revenue, 143x. That's our revenue, and then we need to subtract that by our expenses, which they say is 75,000 plus 65x. And then you could clean that up, but that's the profit function. So we got negative 0.03x squared for the leading term. And then we got 143x, we're going to be subtracting 65x. So we got 78x, positive 78x. And then minus the 75,000 here. So that's our profit, because it's revenue subtracted by expenses. The marginal profit, we just take a derivative. There's our marginal profit. And now they want us to do the same thing that we just did about plug in 1,200 in for x, this time into the marginal profit function. That's negative. So we get positive 6. So since it's positive, the profit is increasing. Okay. And then if we plug in 41,000, you can probably guess this is going to be negative, right? So that's negative plus 78. So I got negative 168. So that means the profit is decreasing. So when they're producing just 6 drills, they're making the profit is positive. They should increase the amount of drills they produce. If they produce, sorry, when they made 1,200 drills, profit was positive. And then when they produced 4,100 drills, their profit was negative. So they want to back up, produce less.